So a lot happened in observability and cloud engineering last month, and I want to talk about some of it. This is the Uptime from New Relic. Distributed tracing is an idea that's been around for a while, but I think its time has come. Monitoring cloud applications is fundamentally different from traditional application monitoring. And one of the biggest differences is that you can't really look at any application in isolation. Time was you could look at metrics from your Rails app and basically know the health of the service. These days, a single AWS Lambda is never going to represent the whole picture. Distributed tracing is an attempt to address this by showing you a request as it's passed between different services. This isn't just a New Relic thing. The OpenTelemetry project is working to support distributed tracing as well. Udeshya wrote a great article this month, linked in the show notes, on how you can implement distributed tracing with OpenTelemetry on your own Golang stack. Over on the New Relic side, we've been gathering distributed traces for a while, but we recently got a new interface that makes it easier to visualize what other services your entity was talking to during this request. It still feels weird to me that we need service maps. I thought they went out in the 90s, but it turns out we absolutely still do, if not more so. In microservice world, there's just too much complexity for us to track in our heads or on the office whiteboard. So New Relic's automated tools, or some kind of automated tools, are always necessary to really connect the dots. Check out some documentation on New Relic's tracing in the show notes down below. All right, let's monitor some Kubernetes with Pixie. On the Nerd Log this week, we took a look at how automagical the instrumentation with Pixie really is on Kubernetes. You don't need to add an agent to your containers. You don't need to spin up a new container. You don't need to edit your application code. You just need a single Helm command to get really detailed data. And I'm talking like process level, what is exactly using your CPU time at every single moment. I didn't really believe this until I saw it demonstrated on the Nerd Log. The secret sauce here is eBPF, technology that can run a sandboxed program in the Linux kernel without changing Linux kernel code or loading kernel modules. I understood that so well, as long as you don't ask me any follow-up questions. On another note, I love how much of Kubernetes monitoring involves drawing pictures. You just don't really understand a cluster with a list or a table, so you need these cool little circles and honeycombs, and the New Relic's no exception. I think it looks really neat. Check out down below how to get started using Pixie today. Well, I'm hungry. Let's talk about ingestion. Ingestion of data. It's not the sexiest topic. How much data are you sending to your observability service? But we gotta do some thinking about how we ingest data. New Relic's language agents can send you a ton of useful data, and you can send a lot more, including logs, with a little bit of config. Even though it's very cheap to send us data and have us store it, there are still many reasons why you'd want to see how much you're sending. Some observability companies will tell you to just send everything. Uncompressed bitmap streams, video frames, everything. I don't want to name names, but let's say their name rhymes with Blunk. This is a problem both when the storage bill comes and when you're trying to find patterns later. This isn't a hard and fast rule, but if you're sending stuff like debug statements and full stack traces from every request, it can have the effect of just sort of adding haystacks when all you really wanted was that needle. The other reason to monitor data ingestion is to look for dips. If you've had monitoring fail, you want to know about that before a service fails and then fails silently. It can just be super duper useful as like an early warning system for your early warning system. Data ingest monitoring is available for everybody today. Check the links below to see where it is in the UI. Do you ever worry that an AI is coming for your job? GitHub Copilot premiered last month, and while it raises some concerns about monetization, the fact is that it's one of those AI tools that actually shows real potential. Is an AI going to write your next contract? No more than a rat is going to drive your car. AI tools aren't capable of handling long strings of complex meaning beyond like a single sentence, whatever the breathless coverage of GPT-3 might lead you to believe. But Copilot is trying to use AI as an assist, one where a human still decides whether the pattern match was good. I'm reminded of the sport of centaur chess, a sort of cheating encouraged tournament where an AI helps a human win at chess, or maybe it's the human helping the AI. Anyway, they're helping each other. With New Relic's anomaly detection, the concept is actually similar. We don't put an AI in charge of your operations and hope for the best. Rather, our anomaly detection system tries to give clues to the humans running your operations. to help explain outages, or, and this is kind of the important part, to see anomalies before those anomalies become failures. If you want to check it out, a great first step is to just start sending anomaly notifications to a Slack channel. Check out what the system is seeing, and I think you'll find it's a useful piece of that observability puzzle. Let's talk about network observability. Whenever we draw a service map like this one, we tend to think about the nodes and not the network that connects them. What Kentic does is it monitors those connections and the dark art of networking that routes and controls traffic between systems. Now, normally this would be the part where I say we're excited to announce a new partnership, maybe thank both engineering teams for working late nights to get the two products integrated, and tell you to talk to your sales rep. But there's something kind of cool going on here. The Kentic CEO, Avi Friedman, saw one of our presentations on the new Relic telemetry data platform and just asked, hey, if this thing is supposed to accept data from almost anywhere, will it accept data from the Kentic monitor?
With our New Relic One partnership, customers can use our integration to add network context into New Relic One from network sources like VPC flow, SNMP, NetFlow, and performance testing. And R1 also converts this telemetry into first-class network entities like router, switch, VPC, or geography, and correlates it cross-stack.
I remember when all integrations were the result of months of API hacking, but New Relic is really changing how it adopts open standards. The telemetry data platform means you can send in all kinds of neat performance data and view it right in your New Relic dashboard. There's documentation in the show notes and a link to the full Nerdlog episode, where I interview the CEOs of New Relic and Kentic about how they work together. This has been the Uptime. If you want to know more, check out the links below or go over to the Nerdlog, where I interview engineers and product managers about the changing landscape of observability. Be seeing you.